Welcome. So now we're going to be solving radical functions, radical equations. So a radical equation is an equation that has a variable in the radicand or has a variable with a rational exponent. A rational exponent is a fraction. Okay? And we'll learn how to solve those too. All right, so radicand, this just means under the radical. All right, rational exponent's a fraction. To solve a radical equation, isolate the radical on one side of the equation and then raise both sides of the equation to the same power. If the radical is not already isolated, this will be our first step. So for example, if the nth root of x equals k, right, then we're going to raise both sides to the nth power, right, and then the radical and the root will cancel the exponent and the root will cancel each other out, right? And then we'll have x isolated, and then x will equal whatever k raised to the nth power is. So when you raise a radical by the same power as the index of the radical side disappears. They cancel each other out. Right? So these really aren't too difficult to solve. Sometimes, though, we can get something called an extraneous solution that I should mention before we get started. So an extraneous solution is when you get a solution that does not satisfy the original equation. Make sure that is in your notes. When solving radical equations, always substitute the answers into the original equation and check. So here the check is not optional. Right? There are going to be 3 types of equations that we'll be solving this year where we have to check our solutions and make sure they're good, because we can get what's called extraneous solutions. And those are essentially a false solution. We did everything right, but we got this answer that doesn't satisfy the equation. So we're going to check to see that all solutions work. They result in a true statement. When taking even roots, take the principal positive root only. Right? When we're solving for something squared, right, we have 2 solutions, right? Because we can raise something positive or something negative to a power and get the same thing. But the square root of that value is going to be the positive only. So when we're solving for radicals, we're not going to have 2 solutions. We're only going to have 1, right? Because when we take the square root, it's only going to be a positive answer. Right? Unlike when you square something, and whether you square positive or negative, you get the same answer. So you get 2 values equaling the same answer, not with radical solutions, right? You're going to have only 1 answer. All right, so these are our steps to solve radical equations. Number 1, isolate the radical on one side of the equation. And these are in your notes. Step number 2, raise both sides of the equation to the power of the index of the radical to eliminate the radical. Your goal is get the radical by itself and then raise to the power to get rid of it. You're going to simplify and solve as you would any equation at this point. Substitute answers back into original equation to make sure your solutions are valid. There could be some extraneous roots that do not satisfy the original equation, and you must throw those out. So make sure you check all your answers. Sorry, I had to sneeze. Here's our first example. I have the steps over there, and I think they're in your notes as well. So we already have our radical isolated. So we're going to square both sides of the equation to eliminate the radical. All right, so we're going to square the 2x plus 3. And we're going to square the 7. Square and square root cancel. So now we have 2x plus 3. 7 squared is 49. And now we're just going to solve like we would solve any equation. We're going to isolate our variable. So we're going to subtract 3 from both sides. So we have 2x equals 46. Divide both sides by 2. X is 23. All right, so now we've solved. We have to check our solution. So we have the square root of 2 times 23 plus 3 equals 7. All right, so that's going to be 2 times 23, that's going to be 46 plus 3 equals 7. And if we add those, square root of 49 equals 7. Well, square root of 49 is 7. That one checks out. Good solution. All right, let's put a happy face next to it because it is a good solution. That's our steps. Now, they're going to be of varying difficulty, but that's the basic idea, right? We're going to make sure our radical is isolated. We're going to square or cube or whatever exponent it is, both sides of the equation to eliminate the radical. We'll simplify, we'll isolate the variable, and we'll check our solution. All right, let's solve another one. All right, so now we have the cube root of 4x minus 7 equals 2. Now we cube both sides because we have a cube root. Cube and cube root cancel, so we have 4x minus 7 equals 8. And now isolate x. We'll solve for x. So we'll add 7 to both sides. So we have 4x equals 15. Divide both sides by 4. X equals 15/4. Don't change it to a decimal. It's easier to work with as a fraction. Trust me. We need to check our solution. All right, so we have the cube root of 4 times 15/4 minus 7 equals 2. Well, 4 times 15/4, that's just going to be 15. So we have 15, the cube root of 15 minus 7 equals 2. All right, so to subtract my cube, there, that looks a little bit better. My cube root, the index there, is starting to get so big it looks like you're supposed to multiply. So we have the cube root of 8 equals 2, and that is true, right? 2 times 2 times 2, that's 8. Right? So the cube root of 8, therefore, is 2. Also checks out. Let's give it a smiley face. That one checks out too. All right, let's try another one. All right, so let's try this one now. All right, so we got square root of x plus 3 equals negative 7. We're going to square both sides. Right? Don't forget, you're going to square all of negative 7 there. All right, so square and square root cancel, so that gives us x plus 3. Negative 7 squared is 49. Subtract 3 from both sides. X equals 46. All right, let's check our answer. All right, here's our check. So we have the square root of 46 plus 3 equals negative 7. That's the square root of 49 equals negative 7. Square root of 49 is, so I don't know why I put a radical there. Square root of 49 is 7. And 7 does not equal negative 7. So this one didn't work out. This one is no solution. Your solution did not check out. Therefore, there's no solution, and it gets the sad face. Because this one is not a solution. Sometimes it'll be a solution, sometimes it won't. Oh, by the way, make sure you're writing in your notes, right? So, remember, you can just pause me, right? So that you can get your notes down. All right, so now we have the cube root of 3x minus 1 equals negative 3. So we're going to cube both sides. So we're going to cube the cube root of 3x minus 1, and we'll cube negative 3. Cube and cube root cancel, so this is 3x minus 1. Negative 3 times negative 3 times negative 3, that's going to be negative 27. Right? Be good to start learning some of these. We need to get the x by itself, so we're going to add 1 to both sides. So 3x equals negative 26, and divide by 3. X equals negative 26/3. Definitely do not change that to a decimal. You'll have a rounding error because it's not an exact answer anyway. And it's very easy to check. So we have the cube root of 3 times negative 26/3 minus 1. Oops, I didn't make my radical big enough. Is equal to negative 3. All right, so 3 times negative 26/3, that's negative 26. So we have the cube root of negative 26 minus 1 equals negative 3. That's the cube root of negative 27. And the cube root of negative 27, right, we just cubed negative 3 to get negative 27. The cube root of negative 27 is negative 3. And negative 3 does equal negative 3. Where's the rest of my sentence? There it is. So this is a solution. And let's give it a happy face. Right? So far all of them have been solutions except for one. Let's take a look at this one. We have the fifth root of 2x plus 1 equals negative 3. All right, so that means we need to raise both sides to the fifth power. All right, so the fifth root and the exponent, they're going to cancel. So we got 2x plus 1 equals, all right, so I'll put it over here. Negative 3 cubed is negative 27. And here, I'm going to put this in. Negative 3 squared, that's negative 9. Excuse me. Positive 9. And negative 3 to the fourth power, that's going to be positive 81, because you just multiplied negative 27 times negative 3 and it'd be positive 81. And if we raise it one more time, so we'd have 81 times negative 3, that's going to be negative 243. So negative 243. Now we need to solve for x, so we'll subtract 1 from both sides. So we have 2x is equal to negative 244, and then divide by 2. And that's going to give us negative 122. And now let's check our solution. All right, so we have the fifth root of 2 times negative 122 plus 1 equals negative 3. So that would be the fifth root of negative 244. Oh, wait a second. Yeah, that's right. Sorry. That is supposed to be a plus 1. Just want to make sure I had the right sign in there, but I'm okay. So we have the fifth root of negative 243, which I said was negative 3. So negative 3 is equal to negative 3. That one checks out. This is a good solution, and it gets a happy face. So far, just one. So why didn't one of the solutions work? The solution that did not work is called an extraneous solution. Extraneous is a false solution. This is the reason why you must check all solutions. Right? So that one back here, where we got an answer, we did all the right steps, but when we plugged it back in, it didn't work. Right? That one was not a solution. This one might have been a little bit easier to figure out why it might not be a solution, but we'll have others that won't be as easy to figure out why they're not solutions. And so we're always going to check. And that's the end of this podcast. And so here are the whiteboard practice, and you're solving for x. And remember to check all your answers. Bye for now.